Hello, everyone. Last week, we talked about different requirements elicitation techniques, including both classical and modern techniques. If you remember, we talked about different classical elicitation techniques, including um, those classical ones that have been widely used and have been proven to be effective in eliciting requirements for a long time, including interviews and questionnaires, as well as the introspection method, and of course, analysis of existing systems. So we call it existing systems analysis, which also includes document analysis and, of course, observation and social analysis. In addition to this, we also covered some modern techniques, including brainstorming, prototyping, the JAD method, workshops, reverse engineering. And also, I have provided to you the differences between each of those techniques, the benefits of using each technique according to each project, as well as some disadvantages of each technique. So some of those techniques could be used individually. Some of those techniques could be combined. It's mainly project-based. Also, in today's class, we will talk a little bit about additional elicitation method that this will be at the end, which will be goal modeling, which is considered as a modern elicitation technique to model requirements by modeling the stakeholder goals. So we're going to talk about this one at the end. So to start today's class, I would like to continue on what has been discussed last week. Last week, we talked about understanding the application domain as the first step in requirement elicitation, following by identifying the source of requirements. Once we have identified different sources of eliciting requirements, we have to perform stakeholder analysis and to identify the stakeholders, their roles, their influence, their power into the project. And then we have to make recommendation on which technique we will use to elicit requirements. As I said before, it is mainly dependent on the project. And then we have collected or gathered requirements. So now we do have requirements in hand. So we have huge set of statements. Requirements at the end are just text. You collect requirements from the stakeholders, the entire set of people involved in the project. And then you have a great bunch of data. This data will be treated as text to represent the set of requirements. Once you have this data in hand or the set of requirements for the stakeholders involved to build such a software to develop the entire project, we have to classify and organize requirements in addition to negotiating and provide prioritization to the requirement. So in today's class, I will be talking mainly about how to classify and organize requirements, followed by prioritization of the requirements as well as negotiation of the requirement. As you can see, there's always a feedback loop between each component in this process. So it's always like a spiral relationship. So once you finish one entity in this process, there will be a feedback by which you might go back to the previous step and then refine your decision and then move forward to the next step. So documentation and validation will be discussed in more details late in next week. And then we also going to emphasize on documentation and validation when it comes to the analysis phase. Now let's start the first entity. After the fact, which we assume we have now requirements in hand. So the first stage is requirement classification. The first stage after we gather the requirements is requirement elicitation and organization. So now we have bunch of text, which we consider as the requirements, different text. The way you're gonna organize and classify the requirements will determine the efficiency of analyzing the requirements. So some techniques, they organize the requirement into hierarchy. So you might look to the requirements as hierarchy level. Some other techniques, they might actually consider clustering of requirements. So in today's class, we will talk about how to categorize and classify requirements into different clusters. So why do we need to classify and organize requirements after the fact we have collected and gathered the requirements from the stakeholders? Because we need to understand how requirements may be organized in a software requirement document. The way you organize the requirements in the software document at the end will help to provide an efficient analysis, will help on identifying the relationship between the requirements, will help in identifying some structure of the requirements that later on could be used in the design phase. That means unstructured requirements are organized in multiple levels of related groups or clusters. So at the end of the story, you would like to group requirements into clusters such that they have common properties, or they have common features, or they have common functionality, or they have common structure. So associated functional and even non-functional requirements would need to be linked and defined throughout the entire requirement elicitation process. Categorization to the requirement with diagram models is considered as a very good appealing way to visualize the requirements. So when we classify requirements, we group them into clusters. As I said before, it might be into a hierarchical level, or might be even visualized using a diagram level that will help in viewing the requirements and later on in the analysis phase. How would you classify and organize requirements? It varies. There is no standard or typical technique to classify or organize requirements. It could be based on the subject itself or the system area. At this point, you might use a system architecture model to identify subsystems, and then you associate the requirements based on the categories within each system and each subsystem. It is considered as an efficient way of classification that has been widely used even in modern software development. Another way to classify requirements is based on the source of data. So if you have requirements that are considered from developers as stakeholders, then you group all the requirements that have been collected from the developers. Or if you have collected requirements from the CEO of the company, then you group all the requirements based on the COO collection. Or if you have requirements from the initial users or like trial users, then you collect those requirements underneath the user category. So in other words, you just need to classify based on the source of the data based on which the requirements have been gathered. Or using the traditional approach, which we have discussed before, is to classify them based on their type. So we have classified requirements before into two main categories: functional and non-functional requirement. So whether you classify requirements as functional or non-functional requirements, each type has its own classification methods, different methodology and different approaches in classifying them. So either functional requirements, we do have what we call category-based classification. If it's non-functional, we do have the properties-based classification. So let's discuss each of those classification in the following slide. Now let's start by function requirement classification. So if I do have function requirements, I was able to classify the requirements into functional and functional. Now I do have functional requirements in hand. In order to better understand and manage the large number of requirements, it's very important to organize them into logical clusters. It's possible to classify the requirements, especially the functional requirements, into the following categories. Actually, you could use any clustering method that could be appeal to be convenient. These are the typical, or we call it the best practice classification of functional requirements. There are many other clustering techniques that can be used to classify requirements. You could classify requirements, especially as I said, functional requirements, either based on their features or use cases, mode of operation, user class, or responsible subsystems. With this classification, it is easier to understand the intent and capability of a given product, and it's even more effective to manage and prioritize large group rather than single requirements. So as you can see here, if we have multiple requirements, and then we were able to categorize them into clusters, either based on their feature or based on their use cases or any other category, it's easier for me now to do the analysis. Instead of just analyzing one requirement at a time, we do analysis of group of requirements. And in addition, it helps in prioritizing the requirements within each cluster. So instead of saying this is priority one, this is priority two, this is priority three, we might say this entire group is of priority one. I will tell you later how to prioritize requirements. But for now, you can see that classification or grouping requirements really helps in understanding the requirements and also to manage the large set of requirements, because requirements at the end is of a huge size. Like we have large size data set of text data. In order to understand this data and provide a good management, which will be later used in the analysis and even the specification, even the management phase of requirements, it's better to provide a classification category for the requirements, by which instead of working on the entire set of requirements, you are working on each cluster individually. So I will focus only about functional requirement classification using features, which is the most commonly technique in classifying function requirements. So in this category of classification, we consider a feature as a set of logically related functional requirements that provides a capability to the user and enable the satisfaction of a business objective. So keeping this in mind, if you decided to use the feature classification method for functional requirements, you have to identify the features of each requirement, which include the name of the feature, the description and priority of each requirement, the stimulus and response sequence of each requirement, and the list of associated functional requirement. So why we do this? Because we'd like to provide capability to the user and even enable the satisfaction of a business objective. This will help entirely on identifying group of requirements that can easily be analyzed in later stages. So once you identify functional requirements, if you would like now to classify them based on the feature, you should define the feature based on those four entities. You have to name the feature. Keep in mind, you have to do spell check. Be careful. And then within the feature, you have to provide a description of this feature, as well as the priority of such requirement. And then you have to provide what kind of stimulus and response sequences should take place. And finally, you have to list all the associated functional requirements underneath this feature. Now let's take an example to illustrate the idea of feature-based classification for functional requirements. Assume now we have a feature, like we have a group that we would like to classify functional requirements underneath it. This group, we will call it order meals. So as stated before, we start by the name of the feature. So this is the name of the feature, which will include later set of functional requirements. We called it in this order meals. So this is like more or less about cafeteria in which meals are ordered. The second entity in the features in which all the requirements will be grouped underneath this feature is the description and the priority. So as you can see here, we have a description of this feature. Let's read it. A cafeteria patron whose identity has been verified may order meals either to be delivered to a specified company location or to be picked up in the cafeteria. A patron may cancel or change a meal order if it has not yet been prepared. So this is the description of the feature. What is the priority of this set of requirements is really high. So we identify the priority of the requirements underneath this feature to be of high priority. Now you have to list the entire stimulus and responses sequence to order a meal. The first stimulus, the patron requests to place an order for one or more meals. The response, what the system would do, the system queries patrons for detail of the meal, and of course payment and delivery instructions. The second stimulus, patron requests to change a meal order. What will happen? If a status is accepted, what would the system would do? The system allow user to edit a previous meal order. And you keep adding the stimulus and the responses. Another stimulus that we might see underneath this feature, the patron requests to cancel a meal order, and then the response, if the status is accepted, of course, the system will cancel this meal order. And all the way down, after it, you need to list all the functional requirements that will be online with such a description, with such properties, as well as to accommodate the list of stimulus and responses. So you can see one of the requirements that was given, the system shall let the patron who is logged in into the cafeteria ordering system place an order for one or more meals. So definitely, this functional requirement should be listed underneath this feature of ordering meals. Let's see the second requirement. The system shall confirm that the patron is registered for a payroll deduction to place an order. This also related to the feature order meal. So that's why this has to be listed underneath the classification category of a feature called order meal, in which we have all the stimulus as well as the responses. We have the priority because it comes of the highest priority to first stage in a cafeteria platform is to order meals. So you can see it is an easy way of classifying functional requirements just by listing the whole description about the entire set of functional requirements underneath it, what kind of actions and responses should be done within this feature, as well as the entire list of functional requirements that have been covered that are related to such feature. If you keep doing this, then you will end up to have multiple features at the end. So this is feature 1, and this is feature 2, and this is feature 3. So you have multiple features. So feature 1, feature 2, feature 3. Maybe you end up to have feature n. So now we have n clusters of features. We will end up to have n clusters of features. Each feature has its own name, and then description, and then followed by priority, and of course, a list of all functional requirements. You will keep doing this for all the features. So now we have a good classifications for all the features, and it's easy to go inside each cluster with a certain feature to classify, to organize and understand and analyze the set of requirements within such feature. This is for functional requirements. As I said before, there are different ways to classify functional requirements. It could be either using features, it could be either using use cases, mode of operation, user classes, or even responsible subsystem classification method. On the other hand, to classify non-functional requirements, we use what we call it the FURPS plus model. So it is commonly used model to classify non-functional requirements. What is the FURPS model? So F stands for functional, U stands for usability, and then reliability, and then performance, and of course, supportability. And plus means any other thing that could be added for classification purposes, including implementation, the interface, the operation, the packaging scheme, and legal actions. So you classify non-functional requirements based on the usability, the reliability, the performance, even the functionality of those non-functional requirements, and the supportability of each non-functional requirement. We use the FURBS model, which is commonly used to classify non-functional requirements. In order to classify requirements based on the FURBS model, there is a checklist that you have uh, guarantee that is completed before you finalize the classification model. You have to use the following checklist when planning requirements, elicitation events, and even during structure walkthrough to verify whether all types of requirements have been covered in the requirement analysis and documentation for later to be covered in the requirement analysis and documentations, such that in the checklist, we have to guarantee that the requirements should cover the following categories. Those categories underneath the FURBS as follow. Functionality, you have to define what the system must be able to, including features, capabilities, security requirements, and even user requirements. Of course, you have to keep documenting them. In addition to this, you have to guarantee that you have all the requirements underneath the usability category. In usability, we list those requirements that are related to the user interface, especially if they are user-friendly or not, are they accessible easily or not, do they look familiar, and of course, do they provide online help or not, and if there's any visual design guidelines available during using those requirements. In addition to those categories underneath the FURBS model, we have to find those requirements that related to reliability. In this, we are looking to the ability of the system to perform under specific routine and non-routine conditions. And should be within a specific period of time. You're looking for requirements that mainly related to the mean time between failures, or the mean time between system and surface incidents, or the mean time to repair. Those requirements that might be listed underneath non-functional requirement, especially for reliability purposes, we'll consider those requirements that are used to calculate the mean time between failures, which is defined as the mean time between surface failures of the same surface. What is the mean time between system or surface incidents? It's the mean time between failures, however, it's of any surface. The third type of requirements should be classified if they are used to calculate the mean time to repair, which is the mean elapsed time to fix and restore a surface from the time an incident occurs. So we can see here different categories that we underneath our checklist. These categories should be checked and verified along the way to guarantee that we are not missing any type of non-functional requirements before even going to the analysis and recommendation and documentation phase. So we talked about reliability. Now let's move to the performance. In the performance checklist category of the checklist, you just need to look to those requirements that describe how the system must behave with respect to either time or even to resources. At this point, you need to include those requirements that are related to speed, efficiency, availability, accuracy, response time, recovery time, start time, resource usage, and throughput. So in addition to the performance, the last S in our FURBS model stands for supportability, means requirements related to those requirements that are related to the ability to monitor and maintain the system, include abilities to test, configure, install, and of course, upgrade the system. So you can see you have the checklist. You start by those requirements related to functionality, those requirements related to usability, those requirements related to reliability, and of course performance and then supportability. And then using this we call the FURBS model, you have to checklist if you have requirements underneath each of those category, such that you are not missing any of those requirements when it comes to the analysis and even the specification phases. These are the typical requirements we're looking for when it comes to non-functional requirements classification. Any additional constraints on the system should be included after those 5 categories. When I say any additional constraints, it could be design requirements or could even be implementation requirements in which we are looking to constraints on the coding and the construction of the system. We might even look for constraints on platforms, coding language, and standards. Additional requirements that or constraints that we might add in addition to the 5 typical requirements categories we're looking for, including interface requirements, which include the capability to interact with the specified external systems and the nature of those interactions, including protocols, formats, and so on. Physical requirements would include those requirements or constraints on the hardware, includes requirements related to size, temperature control, materials, and so on. Finally, legal and compliance copyrights requirements and constraints that are related to privacy. So after you categorize and classify the set of non-functional requirements into the standard 5s and any additional other requirements, you will be surprised that it might end up to have 3 classifications. Either those requirements related to the product, or those requirements related to organization requirements, or even we just call them external requirements. So I'm going to call this my plus requirements. And the 5 sets that we referred to them before, the FUPRS model, will be classified into either product requirements, which we look to some reliability and speed, like reusability stuff, or even we look to a sequence of policies, organizations, and standards, and even some implementation requirements. So which one we will go for it? Are we going to use the 5 standard classification, or are we going to use the 3 classification, which we call the non-functional classification, into product, organization, or external? Yeah, both classifications methods are valid. So as I said before, the most commonly used one is the FUPRS. However, if you read different textbooks and you find them classifying requirements into product, organization, and external, this is valid too. So now let's move to the next stage after we classify and we provide a good organization or clustering to the requirements. So now we have requirement clusters into different groups, such that each group has a common characteristics or properties or organization or even structure, either based on the resource or either based on the features or either based on their own categories of classification. At some point, we need to prioritize the requirements. So requirement prioritization really helps on identifying those requirements of high priority to be addressed first or to be satisfied first. And then if there is some conflict in the requirements, once we provide a prioritization to the requirements, we have to find a solution to this conflict, which is commonly used or solved using negotiation. So my next topic will be on requirement prioritization and negotiation. So the requirements, they have to be prioritized. And when I say prioritize, means requirement 1 and requirement 2. Let's assume we have set of n requirements. Requirement 1 is of priority 1. It should be analyzed or it should be addressed. Different if we have a requirement of priority 2. And if requirement n is of priority 10, where 1 is the lowest priority and 10 is of highest priority, we should look to this requirement in a more focus as compared to requirements of low priority, because each one of those requirements will have a different action. So in requirement prioritization and negotiation phase of the requirement elicitation, Keep in mind that requirement must be prioritized, and because we give different priorities, it might end up to have conflicts. Like assume stakeholder one, say my requirement is of priority 10, and then stakeholder two, requirement I'm going to say n+1, also has priority 10. So we do have now two requirements of the same priority. And if they are contradicting, like requirement N says data should be public, I assume this scenario, so data should be public at some point, and then requirement n+1 said, no, a big issue in our platform is that privacy. We should hide data from external accessibility. So now these two requirements are contradicting. So there's conflict between the requirement. So we have to find a way on solving such conflict. Mainly would be through negotiation, where you will sit with the stakeholders and try to come up with a strategy of handling such conflict. I will talk about this in more details when it comes to requirements, conflicts, and solving. In requirement prioritization and negotiation, it is a process in which we do or perform two main stages. The first stage is we have to first assign priority to each requirement, and of course, find and resolve conflicts through negotiation. How with this done? The second stage is to allow one-to-one meetings with the stakeholders in order to resolve such differences. And of course, they have to agree at some point on common strategy or even common agreement about the requirements, because if there's a conflict, you cannot just proceed to the final specification document that would be provided to the developers, because you would like to end up that all the conflicts between requirements are resolved. So when it comes to development, the developer will take the SRS document from the analysis specification phase and start developing the system. If there is conflict, then it might end up that they cannot actually build a system. That being said, the requirement conflicts and prioritization is very important to be studied. In addition, resolving such conflicts is a very crucial task in the elicitation phase. Keep in mind when I say elicitation, because it started in the elicitation, and because it's a spiral process at the end, or it's like a feedback loop at the end, you might have some conflict appearing in the analysis in which you have to resolve the conflict. Once you resolve the conflict, maybe you need to elicit more requirements to satisfy some facts about your conflict, so you have to do to the elicitation phase again. So it's a feedback loop. Like there is always a feedback between the phases. There is always return and verify action. You go back to the previous stage and verify. But whether I am in the elicitation phase or in the analysis phase or even specification phase, there is always a goal to resolve those conflicts to guarantee that it's conflict free before we proceed to the final design phase. So with that being said, how requirements are prioritized? Requirements are prioritized based on the importance to the overall system. So requirement one, if it's very important to be implemented such that it's a huge part in the system development, then it should be assigned a high priority. While requirement two, if it's not important to the overall system, so it should be assigned low priority. So when we have different strategies, which I will talk about it later, how to prioritize requirements. Now, assume you came up with a priority system that define different priorities for each requirements. When now there is conflict between the requirements and there is a negotiation stage between requirements, please keep in mind that the priority system should be clearly defined. It could be according to different levels or according to different classifications. You could say my priority level could be either critical or high or baseline, low or utility, and so on. There are different prioritization systems that you could be used to assign a priority level to each requirement. And the priority system should be clearly defined even before the conflict detection and resolution, because it helps on resolving those conflicts at later stages. So always requirement conflicts, when they appear between different set of requirements, they should be resolved. And this is actually a matter of negotiation or compromisation. So at the end, after the fact that the stakeholders have met and they negotiated and they compromised their priority of each requirement, a summarization of each negotiation meeting should actually be included in the requirement recommendation documentations. So in addition to the SRS, which we will end up obtaining at the specification, the software requirement analysis specification document, we also will have the negotiation documents. So what are different systems that we could use to prioritize requirements? What are the difference between both systems? In today's class, I will talk about the cost value approach, but let me start by giving you an overall idea of why prioritization is needed. Let's talk about some trade-offs. In addition to a focus on the cost value approach, which could be either by sorting requirements by the cost and value, or by estimating relative cost and value using what we call the AHP method. And then what happened when requirements or stakeholders disagree? That means we do have conflict. I will also talk about different ways of resolving this disagreement. Keep in mind that more details will be provided when we talk about requirement management. In addition to resolving conflicts in requirement elicitation, there will be conflicts also resolution in the analysis and specification and the management phase, and even in verification and the validation phases. So how to prioritize requirements? You need to identify what is important to the system. In other words, you need to select what to implement. So keep in mind that customers always ask for way too much requirements. Also, the balance between time to market with the amount of functionality is a great trade-off. You have to decide which features go into the next release. So those features will be of high priority. Also, in order to assign a prioritization level to each requirement, there are a couple of things that you should elicit or you should have information about, including how important is this to the customer, which is another part of being important to the entire system. And how much will it cost to implement? Because as I said before, one of the main common techniques to do prioritization is the cost value analysis. That means we are very keen of knowing a cost of each requirement to determine if it's high priority or low priority. And when it comes to the value of each requirement, this is when we identify the importance of this requirements to the customer. Also, maybe it's not only about the cost and the value, it might be about the risk. So you need to know to collect information about how risky will it be to attempt to build it. Is it risky? Is it low risk? Is it high risk? That's part of the feature selections about your requirement by which you will identify if it's of high priority, low priority, or even neutral priority. In addition, once the fact that you identify requirements and then you try hard to assign priority level to those requirements, at this point you have to decide what requirements must be included and which requirements should definitely be excluded from the set of requirements. And that will leave us to just a pool of those are nice to have requirements or which must select at the end from. That would be the set of requirements that we select from. So there are different prioritization techniques that are available that you can actually use it to prioritize requirements, including the analytical hierarchy process, the AHP method, which at the end deals with n times n minus 1 divided by 2 calculation at each hierarchy level which I will talk about it in a few minutes. The second one is called community voting. It's called the $100 test. So in this one, you actually imagine that you have 100 units, like imaginary units. It could be money, it could be hours, or whatever. And then you try to assign those units to the requirements, or distribute those units to requirements. So maybe requirement 1 will take 70 units, maybe requirement 2 will take 1 unit, maybe requirement 3 will take 20 units. It seems like this requirement is of high priority now, using the cumulative voting scheme. Another way of prioritizing requirements is the numerical assignment, which is grouping method. In this one, you classify the requirements into just only 3 groups. The first one is the critical group, the standard group, and optional group. It's just numerical assignment without any, it goes into the description of each requirements, and it is manually assignment by the requirement engineer. Another way is by ranking, which is a way of ranking the most important requirements. You give them a number between 1 to n, and then that means you are not working on clusters. At some point, you just rank them from 1 to n. Or you might even return just the top 10 requirements, and you say, I'm not gonna retrieve or return the entire set of requirements. I just want the top 10. So in today's class, I will talk about the first method, which is the AHP, which is a branch of analytical methods that are used widely underneath the cost value analysis approach. So in a cost value analysis, we actually keen on returning and calculating the rate of investment. The ROI will be used to provide prioritization to requirements. How this would be implemented, you need to assess each requirement importance to the project as a whole. So this is step number 1. Step number 2, you need to assess the relative cost of each requirement. So we assess the cost of each requirement and the value or the importance of each requirement. And then the third step is to compute the cost value trade-off. Now you plot the cost on the x-axis, and then you start plotting the value on the y-axis. The cost will be a percentage value, and the percent will be in percentage, and the value will also be percentage. And any requirement that is listed within this range, so this is the ORI curve, and then within we have to find those boundaries. Anything underneath it will be of low priority. Anything within this range, so we have to find the second boundary in the ORI, which is of medium cost and medium value, that will be categorized as medium priority. Anything that is of low cost but of high value will be considered as high priority. We need to perform the 3 stages, which is to assess the importance of each requirement, whether each requirement, all the requirements at once, or even within each cluster of requirements. In addition, you need to assess the cost of each requirement and then compute the cost value trade-off. And then start mapping the requirements in each of those categories by identifying boundary 1 and boundary 2. Anything below boundary 2 is of low priority. Anything above boundary 1 is of high priority. Anything in between boundary 1 and boundary 2 is of medium priority. This is a common way of prioritize requirements using the cost value analysis. How to estimate actually the cost and value of each requirement? It could be done using 2 approaches. Either by using the absolute scale. At this point, you consider the exact dollar value, which as a matter of fact requires an expert to do it. So the expert must be very experienced in the domain that would need to directly or exactly calculate the dollar amount for each cost and value. And the other one is a relative approach. So the relative approach actually doesn't calculate absolute value. It actually calculates relative values. At this point, we're looking for ranges. It could be less than, more than. It could be a little bit of a value. It might be somewhat like vary. So there's a little bit of uncertainty about it, but it gives you an idea about the priority level of each requirement. The relative values are successful way of estimating the cost and value of each requirement because it is much easier to elicit. In addition, prioritization allows you to compare collection or elicitation from the stakeholders. So at this point, you might want to consider that uh, the reason why we use relative values because for the absolute scale method, when we have direct contact with the stakeholders, it might be, as a matter of fact, very hard to quantify differences. So these complications comes with the absolute method of calculating the cost and the value. That's why we're moving to the relative calculations because it might be hard to quantify the differences between requirements. Assume that um, stakeholder says X is more important than Y. So how to identify this important by an exact value? We cannot determine this. Also, not necessarily that all the requirements are comparable. That would make it hard to actually assign an exact value for an exact number for the value and an exact number for the cost. Also, we might be surprised that requirements may not be independent. So there might be some requirements that are mutually dependent on each other. So if you assign an exact value for it, you might have an impact on the exact value of the other requirements. Also, stakeholders might be inconsistent. So if one of the stakeholders saying X is more important than Y, and then another stakeholder say Y is more important than Z, does this necessarily means that X is more important than Z? We are not sure because when you assume that is an exact value, it has to be fully satisfied. And one of the main issue when it goes for exact or absolute values calculations is the conflict of stakeholders. So different cost and value assessment for different type of stakeholders might provide inaccurate calculations for the prioritization level assessment for each requirement. At this point, the usage of absolute value may not be a good option, and you have to do relative calculations of the cost and value to come up with a good prioritization or an accurate prioritization for requirements. As I said before, requirements could be prioritization could be done for each requirement individually, which is a little bit tricky because we have larger set of requirements, so it might take a lot of time um, to process and analyze and actually prioritize the requirements. So it might be easy to do hierarchical prioritization. Hierarchical prioritization, it provides prioritization to requirements within a hierarchy. It could be either a goal tree, which I'll talk about it later as a way of representing requirements, or it could be through non-functional requirement tree. That means to compare between requirements or assign priority between requirements. We are not comparing all the requirements at once because that means huge data set that we have to assign priority to each one individually. We actually assign or compare between requirements and assign priority level within each group. So that means within this group, I'm trying to assign priority within those requirements in this group, and then we assign priority within those group, and then we assign priority within those group, and the comparison will be on this set 1 and this set 2 and this set 3. You don't need to compare with R1 or R2. R1 or R2 would be compared together, while S1 and S2 and S3 would be compared together. This is an efficient way of hierarchical prioritization because it saves time. at some point you want to assign a priority level for each requirement, so it becomes easy for you to analyze and address it, but you don't want to waste a lot of time doing this. So it might be a good way to build a hierarchy of requirements first, which I will talk about it later as the goal modeling technique. And then once you visualize your requirements in terms of goals and build a goal tree, within each subcategory or sub branch, you will actually provide a comparison between those sets. So if we look to the following graph, we can see that for comparison set one, we only comparing those three because they are in the same group. And then for comparison set two, as I said, we compare S1 and S2 and S3. For comparison set three, we just compare R1 and R2. And the idea is cluster the requirements based on the different classifications we have done before, or even different modeling techniques that could be easily used to categorize and group requirements. And then if you'd like to assign a priority level for each requirement, it's not necessarily that you're going to do it for all the requirements at once. It might be a good practice to just go into each cluster and then compare the requirements, assign priority level within those set only. So the most commonly way of assigning priority levels of for each requirement within each cluster or even within the entire set, I'm going to do it in general and then specific within each cluster, is the analytical hierarchical process method. It's a straightforward method that commonly depends on assigning and on first building a matrix. So we will create a matrix. This matrix would be of size n by n. We assume we have n requirements. And then for each element in the matrix, so we're going to build a matrix. This matrix is n by n. So it has requirement 1, requirement 2, up to requirement n, against requirement 1, requirement 2, up to requirement n. And then for each entry or element, which you're going to call it x and y, like assume this x and y, where x is a value. Like x would be like in this row, for example, it's requirement 2 against requirement 2. If I would put it here, so, and this is requirement 10. So my x and y here would be requirement 10 against requirement 1. For each element x and y in the matrix, you need to enter value 1 if x and y are of equal value, and 3 if x is slightly more preferred than y, and 5 if x is strongly more preferred than y, a 7 if x is very strongly more preferred than y, and a 9 if x is extremely more preferred than y. You might need to use intermediate values like a 2 and a 4 and a 6 and 8 if comprises would be needed. Keep in mind, this is for x and y. If you need to plot or to enter the value for y and x, on the other hand, in the matrix, it has to be the one over the x and y value. For example, if my matrix is like this, so this is, I'm going to make it simple for just 3 requirements, R2 and R3, R1 and R2 and R3. Of course, the value R1 against R1 is 1 all the time. It's the same value. If I'm going to say R1 against R2 is half, 1 over 2. So R2 against R1, it has to be 2. If this is 1 over 3, this has to be 3. And if this is 2, this has to be half. And then the second step in the AHP phase is to calculate or to estimate eigenvalues. What is the eigenvalues? Eigenvalues are those common entities that are simply calculated by averaging over normalized columns. So this is easily done by calculate the sum of each column. There will be a running example in a second, just like I'm listing the steps for you guys. And then you divide each element in the matrix by the sum of its column, calculate the sum of each row, and divide the row sum by the number of rows. This will give a value for each requirement. And then, of course, we need to end up to calculate the estimated percentage of the total value of our project. So we did this for the value. As a matter of fact, you can do the AHP. So the AHP method, which I just listed over here, could be used to calculate not only the value, but also the cost. So let's take a running example and see how this actually could be using to estimate the cost. The similar technique is applied for the value as long as this matrix is calculated or is easily defined. So now assume for this example, we do have 4 requirements. So if we do have 4 requirements, R1 and R2 and R3 and also R4, and then we list the n by n matrix, which is my 4 by 4 matrix. And then in this example, assume where, as I said, all the diagonal always is a value of 1 because this is a requirement against itself. And if we this is the cost. So the cost of 1 against 2 is 1/3. So that means the cost of requirement 1 is 1/3 of the cost of requirement 2. The cost of requirement 1 is double the cost of requirement 3. And the cost of requirement 1 is 4 times the cost of requirement 4. So we just put a ratio here between the cost of each requirement against the other requirement. So you can see here, if the cost of requirement 1 to requirement 2 is 1/3, that means the cost of requirement 2 against requirement 1 is 3 times costly. And if requirement 2 against 3 is 5 times more expensive, and if requirement 2 against requirement 4 is 3 times more expensive. So if we do have requirement 1 against requirement 3 is of value 2, that means requirement 3 and requirement 1 has to be half. This 5 goes to 1/5. And as a matter of fact, this 3 goes to 1/3. And at the same, this 4 goes into 1/4. And this 1/3 will be 3 when we flip the row on the column. The second stage at this point is to calculate the sum rows of the sum of the columns. So you calculate the sum of the columns. So if you calculate the sum of the first column, it will be 4.75, and this 1.87, and this will be 11. And this will, the fourth column sum is 833. We simply try to calculate the eigenvalues so we can easily normalize the column. And once we calculate the column sum, you will divide each element by the column sum. So for example, this element, the 1.188 originally is from the 2. So let me take this out. So it would be this 2. So it would be this 2 divided by the column sum, which will this 11. So this is 2/11, which is 0.18. You do this for each element in the matrix. You multiply the element by the column sum. And of course, this 0.27 is 3/11. And this one is 1/833. So once we have normalized all the columns, at this point you start sum the rows. So the 1.05 over here, 1.05 equals to the sum of the normalized column values in row 1. So this is 0.21 plus 0.18 plus another 0.18 plus 0.48 will give you the 1.05. On the other hand, let me show another example, 0.34. This equals to 0.11 plus 0.11 plus 0.09 and 4%, 0.04. And you keep doing this. And then you normalized this value again by dividing the sum over the number of requirements. So this 4 is the number of requirements. So this is the number of requirements. So here we have 4 requirements. So we're going to divide by 4 because it is of 4 requirements. So it ends up that the number we ended up with right now is 0.26. This is for requirement 1. So this is the first row. And then 0.5 for requirement 2. This is 9% for requirement 3, and this is 16% for requirement 4. So if we map this, our result here would be requirement 1 has 26% of the cost, requirement 2 has 50% of the cost, requirement 3 has 9% of the cost, and requirement 4 has 16% of the cost. So now we did this AHP to give an estimate of the cost value of each requirement. So what should we do next? The next stage after this is, a matter of fact, to do it the same for the importance or the relative value for each requirement. So if we do have a similar matrix like this, and this matrix is used for the value or the importance, I can also generate another table like this, which determine the value of each requirement. And then simply you need to calculate the cost value there and plot it into the return of investment graph. So the first step is to estimate the relative value, this by applying the AHP on the relative matrix. So relative matrix, and then you do the same. So the second stage also you do AHP, and this one you're going to do it on the cost matrix. We do this to estimate the relative cost for each requirement, and we do the first step to estimate the relative value for each requirement. And then you calculate the ROI ratio and start plotting the requirements. Any requirements below, as I said, this boundary 1 would be considered low priority, and this any requirements above boundary 2 would be of high priority, and any requirements between boundary 1 and boundary 2 would be immediate priority. Now let's assume requirement 1. If you divided the cost, if it has a cost, let's assume of 10%, and it has a value of 30%. So requirement 1 should be here. And then if we have requirement 2, it has a cost of 30% and a value of 10%. So if my boundary will be 10%, so requirement 2 should be here. And then if we have requirement 3 that has a cost of 20% and a value of maybe another 15 or maybe 15%, so requirement 3 should be here. So now requirement 1 will be of high priority if 1 for me is a high priority, or let's make it 1 of high priority, and then requirement 2 is low priority, so I'm going to say this is 3, and then requirement 3 will be in the middle, so this is 2 if we assume 1 is high and 3 is low priorities. So you can see here it was easy for us to assign priority level for each requirement just based on using the AHP method to calculate a relative value for each requirement and a relative cost for each requirement. We just have a pair in which we'll start mapping the X and Y. The X would be the cost and the Y would be the value. And then plot this into the ROI curve, where we assume that we know the boundary for R1 and we know the boundary for R2. Now you can easily classify requirements into 3 classes of low requirements, of low priority, medium priority, and high priority. So this is very efficient to classify requirements based on the ROI, but as a matter of fact, there are other methods that can be used as a selection criteria to provide priority level for each requirement in addition to the ROI. It could be still using the cost and value approach, but we are not using the ROI boundaries. We're just going to use a sharp split into 4 clusters. So above value, above average value, and then below average cost will be in this cluster. Above average and in both cost and value will be in this cluster. Above average cost and below average value will be in this cluster. So we are not using the boundaries of the ROI. We're just using a sharp split in which we have to identify this line as well as this line to differentiate above average of the cost and the value. We can even use the relative loss to determine priority level of each requirement based on the risk. And that means we plot the relative loss on the x-axis and the relative probability on the y-axis. And in requirements that lies in this range below this probability density function of the priority, it would be considered as low risk. Any requirements above this would be of high risk exposure. Anything in between would be just still neutral. So as you can see here, there are different ways to prioritize requirements. The most commonly one is the cost value analysis, especially with the ROI. I could use the ROI boundary lines, or I could even use the Sharpe division lines of the cost and value, or I could even use the loss versus the probability risk distribution. The common used one is the ROI, but I could define those boundaries, and then it becomes easy for me after I identify the loss and the probability of each requirement of occurrences and uncertainty about it, is to provide a priority level for each requirement. So now we assume that we were able to provide a prioritization level for each requirement, and then stakeholders, each one has received the priority level about their requirements, and at some point they disagree. There is conflict. So how would this conflict is addressed and discovered? So it's very important to discover the conflicts between stakeholders. And it's very important to find a resolution method to those conflicts. So the commonly used method for a conflict resolution is negotiation. But first, let's see, or let's understand more about requirements, about stakeholder conflicts, which ends up to have conflicts in requirements. So requirements and stakeholder conflicts is a crucial task that we should identify, because interaction with the stakeholders may be a tough task. They might have vague knowledge of what they want. Ideas are actually expressed with implicit knowledge. They might even, we might even have different stakeholders would input different requirements, and they might express those requirements in a completely different ways. So we end up to have ambiguity that might lead to conflict, or even we might have some redundant requirements. So that's tricky. How would this be a big deal? It's actually a big deal, because it is a tough task based on the fact that we might have vague, some unclear knowledge, like some vague knowledge. We have unrealistic demands. We have unrealistic expectations. Stakeholders, they can't actually define what they want from the system. Their ideas, when they try to express it, actually, they assume that everybody knows what they want, but not necessarily. Like, without prior experience of the end user environment, an engineer that would like to collect such information may even not understand what the stakeholder wants or what they mean. So that makes the problem very hard based on those factors. In addition to this, you might be surprised that this is not only the reason why it's hard, because another reasons are mainly related to economic conditions or even political factors that may even influence the system requirements. Because we might find that business stakeholders could demand certain functionality to increase their power in the organization. So they try hard to push into increasing this requirement, prioritization, so they can increase their power in organization. So this is a conflict, which is a result of a political factor that definitely will have a great impact on the system requirements. So that's not good to in the entire set of requirements. And we have to discover this conflict first in order to provide a good way of resolving the conflict. In addition to this, you might find some economic and business conditions that are dynamically changes that would definitely might raise conflicts along the way in the requirement engineering process, because particular requirements may alternate or may change or may evolve throughout the process. It might be outside the engineering control. So you might find that the company is actually restructured or even bought out, or even the company is closed or like it's closing soon. So these dynamic business conditions will really have a raise or a flag for conflicts. So the key point over here is it's very common that different stakeholders might be requesting requirements to be included. Those requirements might end up to be conflicting with each other. This is simply a result of conflicting priorities between stakeholders, and they may not realize they are requesting actually conflict requirements. So, in other hand, when we do have those conflict in requirements, the best way after the fact we were able to discover those requirements, we need now to identify a way of resolving the requirements. As I said before, a common way of resolving the requirements is through negotiation, which is a nice way to compromise their demands. In this negotiation meetings, stakeholder whose ideas are voted down may try to undetermine the rest of the purpose due to some like spy thing. And it's very important during this negotiation phase that any conflict as well as resolution decisions to be recorded for the documentations and of course for archiving purposes. So an example of conflict requirements, let me share with you, like example of conflict requirements might be from one stakeholder, like the human resource. They said they explicitly request to capture, so this is their requirement, explicitly request to capture the age of the employee. So this is requirement one from stakeholder human resource. And then we have another stakeholder with like who is the data privacy team. And then they said the age of the employee may not be captured or used in reporting. So this is requirement two. Now you can see requirement one from stakeholder one and requirement two from stakeholder two. They are conflicting or contradicting. We say two requirements are conflicting if you cannot implement them both at the same time. That means if you have a solution in hand, when you try to implement one of those requirements, it will prohibit you to implement the other requirement. So another example, if you would like your product to be available to all customers, and another requirement says it's fully secure, so it's not available for everybody, then these requirements cannot be implemented as a specified. It's hard to satisfy both requirements at the same time. So that means there is a conflict, and as I said, it is a conflict that should be addressed first and then should be resolved next. There are different level of severity of conflicts. We call it severity of conflicts. For any two position A and B, so assume in this graph, we are listing the satisfaction of party A, and assume this is my satisfaction, like party A satisfaction, another party satisfaction, and for any two initial positions A and B, how would we measure the severity of the conflicts between my satisfaction as a stakeholder and another party satisfaction is by examining what will happen when you combine these two options or two positions. So if this is my satisfaction as an A and this is the B satisfaction, as you can see, they are mutually exclusive. When we combine them, we end up to have zero satisfaction. On the other hand, if my satisfaction is the severity of the two conflicts, if this is my satisfaction over here and still I have the other part satisfaction here, but we compromised like the conflicts between the two parties. So we say A and B, when they combined, we are interfering. So our severity of the conflict is interfering. So it could be mutual exclusion, or it could be just interfering conflict. If we, this is my satisfaction, this is B satisfaction, and we reach it up to the highest level of satisfaction between A and B, so we say it's non-interfering. And as a matter of fact, if the satisfaction of A could be satisfied within satisfaction of B, so we call this is inclusive satisfaction. So you can see this, the conflict, requirements conflict could be of different level of severity based on when you combine them, You need to examine what will happen when you combine them. Would you end up to have completely disagreement? That's a mutual exclusion. What I want is against what you want, so there's nothing to be done. Or we could have interfering shaded area where we could find a common way of agreement, or it's not interfering, or it could be even inclusive. If my decision could be easily jumped into, my satisfaction could be easily jumped in your satisfaction, and we have an inclusive agreement. So if we go back and try to find what are the main causes of the requirements, back in 1973, it was due to control over resources, also preferences. It could be the taste or even activities of one party has actually prioritized over other parties. It could be according to the values. You might have a claim that a value or set of values should dominate any other values. It could be according to beliefs. It could be according to some information or even reality. And also the nature of the relationship between the parties would have a great impact on the prioritization and causing conflicts. So this was listed by Deutsch in 1973. Robbins in 1989, he has listed some other causes of conflicts, including communication, communicational causes. Assume we don't have enough information. There is noise about the data, and it might be structural, like the leadership style might have caused such conflicts, as an example, or it might be related to some personal factors like personality characteristics that are causing those conflicts. So whether we have different causes of conflicts, it was claimed some interesting results that behavior and conflict are normal in small group decision making. Also, more aggression and less cooperation when communication is restricted. So we also noted that a decrease in communication tends to intensify a conflict. In addition to this, heterogeneous system experience. So if you have a team that it is composed of different level of expertise, actually will cause more conflict. While we have homogeneous groups are more likely to make high risk decisions. So although they might have less conflicts, but if we have groupthink and they are homogeneous in their decisions, there is a chance of less conflicts but high risk. Also, the effect of personality is overshadowed by situational and personal factors. So these are very interesting results from papers published by Deutsch in 1973 and by Robbins in 1998 to come up with a fact about what could we observe is small group would have a larger chance of conflict. Yes. If we have heterogeneous groups, yes, there is a chance that they have more conflict. If we have homogeneous group, it might be less a chance to have conflicts, but high chance of high risk decisions at the end. Basic approaches in conflict resolution, including the first one, which is very commonly used in many platforms, is negotiation. It's all about collaborative exploration. At this point, we know that people are setting, they are willing to negotiate. Participants would attempt to find a settlement. This settlements would, in fact, satisfy all the parties as much as possible. Negotiation is also known as integrative behavior strategy to resolve conflict. And sometimes it's called constructive negotiation because they do have the willingness to come up with a compromisation. So that's why it's a constructive negotiation. It's integrative negotiation. This is completely different from the competition, which is the destructive and competitive negotiation, which is another way to resolve requirements. At this point, they are competing. Competition at this point is used to maximize your own goal. So you are to compete to maximize your goal. And once you win, so any other conflict with other requirements will be resolved because all other requirements, as a matter of fact, will not be implemented because you won the case. So in competition, there is no regard for the degree of satisfaction of other parties. It's just about winning the fight of proving that your goal or your gain has to be maximized. A third method in resolving conflict is called third-party resolution. In third-party resolution, they are not able to negotiate, and they decided to have a third party in place. And participant at this point, they appeal to outside source. It could be a figure of authority, it could be according to a rule book, or could even be a toss of coin. The third-party resolution method can occur with the breakdown of either negotiation or competition as resolution methods. There are different types of third-party resolution, including some cases that presented by each participant that would be taken into account, or could even be extra third-party involvement in which a decision is determined by factor other than the cases presented. It could be according to relative status of the participants, or could be even arbitrary in which we do toss of a coin. So as I said before, it could be different types according to is it related to the cases raised? Is it determined by other factors, by factors that are not related to the case presented, like some relative status of those participants, or even could be just a toss of coins. So these are different ways of conflict resolution. And actually, in many of the construction projects, I have seen this a lot, that a way of conflict resolution is done through bidding and bargaining. So bidding would involve the way in which participant would state their desired terms, and then bargaining in which participant will search for a satisfactory integration of their bids. So these are commonly used in construction, but also we have seen a lot lately in software development. So far we talked about requirements classification organization. We also talked about requirement prioritization, conflicts detection, and conflicts resolvement. So now let's allow me to show you another way of gathering or elicit requirements, which is commonly used not only in the elicitation phase, but we can also see it in the analysis phase as well, which is goal analysis and modeling. So what is a goal? A stakeholder objective for the system. At this point, the system would include the software and its environment. So if the system, when we say a stakeholder objective related to the system, what is the system? It's just the software and the environment. We talked before about stakeholders. That will be any person, any individual who would has interest in the system, including customers, end users, system developers, system maintenance, and so on. Now, what is a goal model? So we first have to identify a goal, which in our case will be a requirement. So as I said, goal modeling is another way of elicit requirements in a better visualization platform in which it's easy for us to gather requirements and immediately build a goal model for the requirement. The goal model is a hierarchy of goals. So you have to list the set of goals and then build the hierarchy of goals, and then relate the high-level goals to the low-level system requirements. In this way, it's easy for you to visualize the requirements. It's easy for you to relate them as goals of the stakeholders to the system. It's easy for you to identify which ones are of high-level goal compared to low-level goal. And as a matter of fact, it would be later good to identify which ones are hard goals, which ones are soft goals. So where do goals come from? They could actually conveyed even by the stakeholders when you meet with them, when you meet with the stakeholder and start collecting requirements. And then you try to come up with those lists of requirements that identify the stakeholder objective to the system. And then another way of eliciting the goals is to disclose, do you find them in the requirement documents? Or you could do it through the analysis of similar or current system, or even by elaborating other cores and divide a goal into sub-goals, you can easily find some other sets of goals. So how would when it's important to model the requirements into goals and then build a goal model, it is really good because it is reasonable, intuitive. It provides explicit declaration of goals in a way that it helps in identifying the sound basis of conflict resolution later on. However, it captures a static picture. Would be the goal? What would be the goal model if the goals changes over time? So if you build the hierarchy of goals, so these are my set of goals based on their importance to the stakeholders as well as which one satisfy the objectives of the stakeholder to the system. And then this is static picture. It should yeah, at some point when the requirements or the goals would it change over time, how would this diagram or this goal model would it change? Also, it could be another major disadvantage of goal modeling is it can regress forever up or even down the goal hierarchy, so we can see it forever going. So we have to stop at some point. So how would to identify if it's a goal or not goal? Let's take some examples. If I said credit card information is kept private, that's goal. The credit card information is accurate, that's a goal of the stakeholder to the system. This system has to provide safe transportation. This is a goal that need to be achieved. The system should be of high reliability. That's a goal. What is not a goal? If we said the system will be implemented in C++, that's not a goal. Like we know that's implementation language. The paint color of the car will be yellow, orange, and red. This is a requirement, but it's not a goal to be met. So that's not a goal. So if we about to build the hierarchy of goals, it's important to identify which goals are of high level versus which goals are of level concern. Let's look to the following set of goals and try to list them from the high level concern to the low level concern. The first goal is user receives a request for a timetable from a system. The second goal, collect timetable by the system. The third goal is schedule meeting. And then the fourth goal, system collect timetable for user. And then the fifth goal, collect timetable. If you looked at this and try to come up with a list of goals from the high level concern to the low level concern, you will be surprised that we first have to do the schedule meeting, try to collect timelines by the system, and of course, the system will then collect timelines from the users, and finally, the users will receive requests from the timetable. So it's very important to build a goal model to identify the high list goals versus the high level concern goals versus the low level concern goals. What are type of goals we can see? Keep in mind goals at the end are requirements. So if we classify them, it looks like similar to the requirements classification. It could be a functional requirement, function goals or non-function goals. Sometimes we call it hard goals versus soft or fuzzy goals. In functional or hard goals, we describe function that must be carried out. In other words, those functions that the system will perform. It has to be well defined for satisfaction. Like the example we discussed before, like the system collects timetable from the user. This is a hard goal. This is all about functionality of the system. Sometimes we called the hard goals as satisfaction goals or even information goals. On the other hand, the non-functional goals, they are those goals that cannot really be fully satisfied. So hard goals, they must be fully satisfied. So that's why we call them satisfaction goal. While the fuzzy goals or the soft goals, they might not be really satisfied. They more or less describe the desired system quantities. It's really hard to define them. That means it's really hard to satisfy them. More or less related to reliability, if we have an example, the system should be reliable. What is the definition of reliable? We cannot actually quantify it. The system should be of high quality. What is the definition of quality? We have to find a measure for this. Similar goals could be related to accuracy, performance, and security. When it's related to non-functional requirements, they're related to something like reliability, quality, accuracy, performance, and security, we will classify them as soft goals. If it's related to satisfaction goals or even information goals, they will be hard goals. So the following graph actually provide a more detailed classification of goals. It could be function goals, or it could be non-function goals. For function goals, it could be satisfaction goals, information goals, or STEM response goals. For non-function goals, you can see we have a lot of them. It could be quality of service goals, it could be compliance goals, it could be goals related to architecture, or it could be even goals related to development. For quality of service goals related to safety, security, reliability, performance, interface, and accuracy, architecture and installation, distribution and development related to cost goals, deadline goals, schedule goals, variability goals, and maintainability goals. Underneath security, we might find confidentiality goals, integrity goals, availability goals. For performance, we care about time, space, and cost. And for interface, we look into the user interaction, device interaction, or even software interoperability. For user interaction, we're looking for usability goals and convenience goals. So you can see there are different categories for the goals that we should identify. It looks like similar classification of requirements into function and non-functional, but here we do have also subcategories. So when and why to use goal models? The best practice is to use it during the requirement elicitation phase, in which we have to focus on identifying the problems, exploring the system solution and alternatives, and of course, it should be done before any UML modeling. Why we use goal modeling? Because we'd like to find a rationale for the requirements. We need to identify more or less stable information. And of course, when it comes to the analysis stage, we guide this phase. We guide the elaboration and the analysis phase by providing a good visualization of the goals, their hierarchy, and their relationship. Let me share with you the first goal analysis approach that is commonly used, which focus actually on why the system is required. We identify why in terms of stakeholder goals, and then we use the goal refinement to arrive at specific requirements. In a goal analysis, we document and we organize and classify goals. And then later on, if the goals are evolving, we need to refine the goals, elaborate those goals, and of course, we have to provide a classification of the operation goals. The goal hierarchy as part of the goal analysis, which later would be used for goal modeling, it shows both refinement as well as alternatives. Let me share with you a running example. So let's assume now we are building a meeting scheduler. First, we need to identify some of the goals into this this example in particular. So the meeting scheduler is designed to assist the initiator in scheduling a meeting, such that meeting should be convenient for participants, and at any time the participant should be available. In the goal modeling, we're going to use the RI star location, which is the commonly used I star goal notation. So in this figure, we can see that goals are refined into sub-goals in which they elaborate how the goal is achieved. For example, if we'd like to achieve a goal which is collect information from user, how this is done either by sending request and receiving request from the users. And now if you would like to collect timetable by the system, it could be done either collect from agents or collect from users. So now this goal is actually refined into some other sub goals. From the bottom of the tree, we go, this is the hierarchy. So we go from the bottom up to build up the final goal, which is the scheduled meeting. So this is our goal that we need to build. And to build a scheduled meeting, we have to, according to those definition, we have to define sub goals. We have to collect timetables, which could be done either by person or could be by system. From the by system, it could be by agent or it could be by user. From the user collect information, it could be either by sending or receiving. The same also for the scheduled meeting. We need to choose the schedule. The schedule could be either manually or could be either automatically. Some of those goals must be satisfied at the same time, or some of those goals might be one of them is enough. So, for example, by person and by user, I think they should be or. It could be collect timetables, it could be by person or by system. While if you are collecting from user, you have a send request or receive request. In some other things, I will show you in some other goals, the refinement could be either or refinement or it could be and refinement. Like this, pretty much like sure it's or relationship. It could be either manually or automatic. Here we might even assume it's and. That means it's collect from agent and collected from the users. So this is very important when you build a goal model, a hierarchy of goals. You identify the high level goal. So this is the first one that we call the high level because it's at the first level the highest level that we need to reach it at the end. And then you try to refine it into sub goal all the way down to the tree. And once you build or identify the set of sub goals, it's time for refinement. So it depends on different type of goals. It could be hard goals. As you can see here, all of the goals in this diagram or this figure are hard goals. They're related to functionality of the system. They are actually not related to any non-functional requirements. On the other hand, we can also see some soft goals, which we can easily also implement it in the tree, which are treated as those goals that it's hard to be defined or can never be fully satisfied. Like the word access to be secure, not necessarily that can be fully satisfied. As I said before, they are related to quality, they are related to non-functional requirements. So if we are studying a train system, we have set of soft goals, which is improve safety. It could be subdivided into some other sub goals like maintain safe distance or clear signaling. Minimize cost, that's another soft goal. Minimize operation cost or minimize development cost. To provide this, we have reduced staffing. For serve more passengers, it could be add new tracks or increase train speed or add more frequent trains. So can I model soft goals? As a matter of fact, to build a complete goal model, you have to list all the soft goals as well as all the hard goals. So once you list either the soft goals and the hard goals, you have to find a way for refinement. As I said before, the refinement could be either using and or could be using or. We call it and refinement or refinement. What is a goal refinement? It's a way of expressing how a more abstract goal can be established by a set of other low-level goals. When we use the and refinement, that means all of the sub-goals must be achieved in order to the upper goal to be satisfied or achieved. So here to collect timetables and to choose schedule, to send request and to receive request. On the other hand, you can see the refinement here is or. So this is by person or by the system. The by system could be by agent or it could be by users. Here manually or it could be automatically. So it's very important to identify the refinement, either an or refinement or and refinement. Sometimes different system will interpret the or refinements in a different way. So if we are talking about static systems, the or is more into identification of alternative solutions. So it could be manually or automatically. So we say the first solution is manually scheduled or it could be automatic schedule. If we are working on adaptive system, so the or refinement is used as a point of variation. It's still related to finding alternative solutions into your goal development. So A basic strategy in building a complete goal analysis is a matter of fact a process that would start by goal elaboration, in which you try to identify those why questions, in which you will label the higher goal related to the context. If it's related to operation, mainly you're looking for the how questions, that will be lower goals, and how else questions, they will give you alternatives. In addition to this, it's very important to find the relationship between goals to build the entire goal hierarchy. If we see a plus sign, this plus sign means one goal helps achieving another goal. If we see the minus sign, that means one goal hurts the achievement of another goal. If we see double pluses, that means one goal makes another goal. That means the achievement of goal A guarantees the achievement of goal B. If we see double minuses, that means one goal breaks another goal. In other words, the achievement of one goal would prevent the achievement of other goal. And also, we have to know that there is a preceding order. So that means must achieve the goals in a given particular order. So if you look here, the study hard goal helps. If you study hard, you will get good grade. So that means the study hard goal as a soft goal for me will help in achieving the get a gold grade. However, if you get a full-time job, that will hurt on studying hard because it may affect on your study. On the other hand, if it's mixed, if you like to make a good income, that means the relationship between the get full-time job to the earn an income is really a good relationship. So that means A is making B. So the achievement of A would definitely guarantee the achievement of P. On the other hand, let's assume this is attending classes or lectures is C. We say that if you got a full-time job, it will breaks the chance that you are attending classes. So that means the achievement of A would prevent the achievement of C. So this is very important to build a goal analysis, a goal model at the end. First, you have to identify the soft goals, you have to identify the hard goals, you have to identify the relationship between the goals. And then once we identify the soft goals and then we identify the hard goals, and most importantly is you have to evaluate what are the hard goal contributions to the soft goal contributions. So in this example, this ellipse is used for the hard goals. The ellipse shape is used for the hard goals, while this cloud shape is used for the soft goals. Again, you do refinement for either the soft goal or the hard goal. And also you have to evaluate the hard goal contribution to the soft goal. So if the schedule is automatic, this schedule will have less participation. So that's why the relationship is negative. If the schedule is automatic, there might be no chance of conflicts. If the schedule is manual, so there's a high chance of having good participations. If the schedule is manual, so it really maximize the conflicts. So you first list the hard goals or the soft goals. Actually, step one and step two may be alternatives. So you might start by the soft and then the hard, or the hard and the soft. And the third step in the goal analysis process is to define the hard goal contribution to the soft goals. When you look into this graph, it's easy for you to identify which goals are hard, which goals are soft, what are the relationship between them. And as a matter of fact, it'll help us on identifying priorities at the end. So that's why goal modeling is really important to model requirements, in addition to provide further analysis and specification later on. So let's take another example in which we consider soft goal as selection criteria. So you can see the set of hard goals here and the set of soft goals. And then most importantly, at some point, is to list the relationship between the soft goals and hard goals. This is for the development case study. Like if you would like to build a train, what are the expectation of the soft goals that you need to achieve in addition to the hard goals? And you have to list the relationship, either plus or minus, double pluses or double minuses. So, summarization of today's class, we talked about requirement classifications, requirement prioritization, including conflicts and resolution. Also, we talked about different methods of resolving conflicts, including requirement negotiations. Also, we talked about goal analysis, in which we have to identify soft goals, hard goals, and relationships. Next class, we will focus more on goal modeling in more details. Thank you for listening.